So today we got the medium problem 2013 that takes squares. Basically we have a stream of points in an xy plane. We can have duplicate points, they are counted as separate points, and we want to, given a query point count number of, we either get to add a point or we have to, for a given point, say how many axis aligned squares are there with that point, meaning that they are aligned with x and y axis. Now since we have to, how many triplets we have to choose, because triplet always define a square. Now it depends on the coordinates of the points. Looks like it's 1000 and there is 3000 calls in total. So what we want to do, because essentially we only care about points in this column and this row, and then we go through points, so we get a query point, and then we go through all points in this row except the points at our coordinate, and each of them has some distance from here, right? Now then we go through all column points, or no, we actually just have to check. No, we know this distance, so we just have to check if in that column there is something up. This is what, 8, so we have to check if there is something at 18 or at 10, and then we count number of points at that exact coordinate. Theoretically we could compress it so that we just get count for each, but and for same for here, but doesn't matter. So this should work. Since these are coordinates like are small, then it should work just fine. Alternatively, if we wanted to do this in like faster time but more memory, I think it would be possible to do this in n squared memory, but log or O1, so that we would like pre-calculate how much is in each column and then like use a sec3 to update. We would have to do range updates, and then we could do like n squared memory and log n queries. Anyways, let's do this. So what do we need to do? Row, column, and then we also need count because we are gonna go through no, not through the default dict int. Okay, now when we are adding a point, then we do self row point 0 self call point 1, right? And then for what this is row, no, the lambda x lambda default dict int, yeah, because we want to have a double map. Row is 0.1 actually, and then in column which has coordinate of x, which is the first one, and then this. Okay, and then we go for row column in self row okay, for row column in here, and now in 0.1, right? If RC So then the difference is ups point, so that's its column. So 0.1 minus column this is column and this is count. And now if column is equal to 0.0, we continue, otherwise we get 0.1 minus column. Now and then we want to ans plus equals and then count times. Oof. So we are going through the row, right? So let's say we get this query point and then we are going through C of 3 and count of 1. Right, and now C3 is not equal to this, so we don't continue. Distance is 0.1, which is row column, so this minus column, so 8, and then we want to do ans plus equals count, which is how many points are here. Such that the 3 points and the query point. Oof, that's tough, bro. I misread it. Not really that tough, but you know, once we select that, I also need to check this, right? So if self row, you know what, I'm gonna do this xy point because I can't be bothered to do this, right? So row is y, and if column is equal to x, and then this is y, right? And now if row of y and then this is what so column minus distance is it really that though? Because no, this should be, because I have C here, right? Because that's the column, that's the point in, and then y minus d, right? And self row y minus d x, then ans plus equals, and then we have to take minimum of these, because if I have 10 here and 10 here and 2 here, then we can still make just 2. So ans is min of count self row y minus dc self row y minus d x, right? And now if self row y plus dc and self row y plus dx, this will be such a pain to debug if I don't get this. And then I think that's it actually, because we are counting all possibilities, so technically I don't need this, I think. Okay, wrong answer immediately. Let's go. So first get that x squared, add, and then we go for the first count with 11, 10, right? Print xy c count. Let's see. And after all this, we'll print so that we know where we are. Now this is 11, 10, and we get 3, 1, right? Now we want to do also distance. 7. How is that a 7, bro? What's that? No, we want x distance, which is x minus that. Okay. So afterwards, there is 2 ways because we got 2 points here. That's interesting. That's straight up interesting. Okay. Okay, so I think this is, and so what we need is actually multiply, because this we fix these 2 points and then we compare with any of these two, so it's count of this times this times this, so it's actually just count of this plus count of this. I can remove this and this and this, and it should work. Okay, it's quite simple enough, I guess. Let's see if someone crazy found. You know, you actually need 1 dictionary, but that's okay. Okay, he got it even easier. Okay, I guess that's better, but technically it's iterating over all points and I'm just iterating over all points in the row, so it doesn't matter. Whatever. Anyway, so brute force O and per query intuition. 2 points, always define a 2 points in a row. Define a square given by the square with width equal to their y coordinate difference approach. Then if those points are x1, y1 and x2, y, then we can have a and v is equal to ups x1, x2 then there can either be a square above the points or the other points being x1 y minus d and x2 y minus d below the points same but y plus d. Y plus d for the approach. Note that there can be multiple points with same coordinates. So if we have a count, same coordinates, so if we have counts so for each row we will have a dictionary where keys are columns and values are the counts of points with that pair of coordinates. Then when we get a query point, we iterate over all points in the row which are not the query point, and that gives us the mentioned earlier length of the square d. Now, given a points, a copies of lower left corner, b copies of the upper left, b copies of the upper left corner, and c copies of the upper right corner of a square and a single query point in the lower right corner. How many squares can be constructed? Well, we fix 3 corners and then have e.g. a options for the last one. How many ways to fix the rest? How many ways are there to fix the rest? The b times c times 1 b times c, so the answer is for given point in the same row as query is, and we also have and we add this for above and below triangle, no, square. O enter query where since worst case all points are in the same row. Okay, space complexity, since we have to store all points. Okay, can't post, goodbye.